Good morning, good afternoon, and good evening, everyone. Thank you for joining us from wherever you are in the world. I am Helen Nachiguli, your host for today's Ask the Expert session, which is part of the ITU Digital Transformation Dialogue series. Before we get started, please note that all audience questions will be addressed during the Q&A window, during the Q&A session. After the discussion, you can submit your questions by typing them in the Q&A window, which can be found at the bottom of your screen. Please remember to indicate the city and country you are connecting from. The recording of this Ask the Expert session will be available on the event website after the event. Before introducing today's session, let me briefly introduce the ITU-T Study Group 5 on Environment, EMF, and Climate Change, the SG5. The SG5 plays a critical role in promoting environmental sustainability within the ICT sector. As the lead group on environment, climate change, and the circular economy, the SG5 develops standards to reduce the environmental impact of ICT and supports other sectors in their sustainability efforts. This includes work like circular design, circular scoring, aimed at creating sustainable and recyclable products. So by setting global benchmarks, the SG5 ensures that ICT advancement contribute positively to environmental protection and resource conservation, fostering a circular and sustainable future. Also, from 7th to 9th May this month, we gathered in Burkina Faso to celebrate the 15th Symposium on ICT environment, climate change, and the circular economy, focusing on digital solutions for a sustainable future. And one of the days during the symposium was dedicated to emphasizing the importance of embracing a circular economy in the ICT sector. We also discussed priorities for the African region and the crucial involvement of African countries in the standardization process. Our theme for today is assessing the circularity of ICT goods. And we are fortunate to have Leandro Navarro, a co-rapporteur of question 7 under the SG5, and which is on e-waste, circular economy, and sustainable supply chain management. Leandro is also a professor at the Polytechnic University of Catalonia. He will walk us through this important topic. And our focus for our discussion will be the ITU-T Recommendation L.1023, an assessment method for circularity performance scoring. Thank you. Leandro, you're welcome, and the floor is yours.
Thank you so much, Helen, for the introduction and for hosting this meeting. And I'm going to share my screen, and I hope then you can follow my presentation. So I hope you can see the slides. Together with Nevin Tevfik, we are co-rapporteurs of question 7 study group 5. And this is one of the recommendations. In fact, there's been 2 editions, and we are going to talk about the latest one, which was consented and published in about 1 year ago. So it's simply a sample of the many recommendations we produce. And then as Helen introduced, the context is study group 5, question 7, and then within question 7, this work addresses particularly things to take into account during the design of products to consider circularity and environmental sustainability. As I said, there are many recommendations here. You can have a kind of map of aspects that have to do with different circular economy steps. And well, you see here that system design is one of them, but there are others. And then, well, as I said, we are going to focus on the circular economy. And within the circular economy, this comes from supplement 28, that among many definitions, it talks about the circular life of products, in which, as you can see, well, there are natural resources, the materials acquisition phase, the production phase, the use phase, with many loops like repair, end of first life, let's say, refurbishment or preparation for reuse, or even remanufacturing back to the factory, and then use again, and so on. Sometimes this at the end of a life cycle, we look back to the recovery of materials. Sometimes, well, there's only an energy recovery, and finally landfilling the remains. So we try to be in this virtuous cycle of high value. And then there are several techniques that can be, or you see here is several, but we are going to focus on that, on the design phase, on the what we call it eco design, because many decisions taken at the design phase, not even at the manufacturing, but at the design phase, predetermine the aspects of the circular life of products. So how many loops we can have, how long they can be, what to do when the product becomes waste, and how to keep it in high value. And we're talking about the circular economy, but it's quite linear and quite unknown because, well, we generate a lot of e-waste because we produce, as humanity, a lot of devices that end up at some time or another into waste. And here you have just a link to where you can look at the Global E-Waste Monitor that has been recently published. And there are many statistics. I mean, if we take like a global average, which is, of course, very misleading for many countries, it talks about the production of near 8 kilos of e-waste per capita per year. And regarding this huge amount of e-waste, well, only a fourth of it is documented that has been properly recycled. I mean, that using state-of-the-art techniques, we have achieved to minimize the environmental impact of it. So it's very important, as I said, to make sure that products last as long as possible, that when recycled, things can be separated, and this has to do a lot with design decisions. This is also from another ITU-T recommendation, L.1023, which says that we have to reduce our e-waste production. And just one kind of short sentence from that recommendation says that we have to increase our e-waste recycling and legislation regarding e-waste. But this is just the last part of what we call it the waste hierarchy. Is that okay? Yeah, we need to recycle, recover, whatever, and disposal. But this is the last resort. Before that, we have to prevent waste, probably because we need to decide carefully if we need to buy or not, or we need to produce or not a given good, because, well, it has a big environmental impact. Once acquired or produced, we have to make sure that the lifespan is as long as possible. Means, for instance, that it might not be useful for us, but it might be useful for someone else or for a different use. So as long as it is usable, it has a value. And then, of course, when it's no usable by anyone for anything, then good recycling is the way to go. In fact, circular economy is very complex. This is a diagram. I'm not expecting you to take a detailed focus now, but it shows that products evolve over reuse, mean manufacturing and all the related processes, the use phase, and then the after use phase or the post-use phase, when it is no longer a product. And then you see that this is the horizontal axis is, let's say, time, and the vertical axis is value. So, of course, raw materials, I mean, in kilograms, are precious, but not as when they become a part or when they get assembled and they become a piece and then becomes a packaged product. So the highest possible value is when the product is completed and then it can be sold and used. And then, of course, after the end of this life, they lose value, or maybe we can think that this line is not horizontal, but it reduces a bit the value and becomes non-functional. And then there are many ways to make sure that the product returns to this high value scenario, or at least it can become industrial, let's say, product that can be then converted into a new product. So this is kind of all the loops. And design is this process that happens before manufacturing that predetermines how easy or difficult this is going to be, yeah, or how long this horizontal use phase is going to last. And well, since producing is so expensive, we have to make sure that maximizing lifespan means the price per hour of usage reduces, and the impact, let's say, of this usage also is reduced in nature. So we are going to focus on this design phase, yeah. And then, of course, every let's say ICT goods manufacturer might have its own way of analyzing the decisions in their design phase, and also focus on particular processes, like say, well, I'm designing my product to be disassembled, or I design my product to be easily recycled, or I design this product so that in the future it can be brought back to a factory and transforming into a new product. And there are many designed for whatever, and then these are let's say techniques or goals that can be taken by designers, and then the objective of L1023 was to harmonize a set of criteria and rules to assess that those decisions and how well the product is in terms of circularity and environmental sustainability. So it's not intended to produce a global score or anything like that. It's simply a methodological tool to classify the properties of that design, maybe compared to other design options. So, and then the objective is that all, let's say, good ICT good manufacturers, they can follow similar criteria when doing that. So there are several definitions in the standard. You can see here some of them. For instance, as I said, eco-design is a form of design in which we try to reduce the impact. We try to keep the product as long as possible in the market. We have the definition of ICT good, the definition of circular economy, the idea of this alignment with circular economy. But basically, there are three circularity aspects, which is product durability, ability to recycle, repair, reuse in the equipment. This ability is also, from a manufacturer perspective, what infrastructure manufacturer offers, and then some kind of indicators. So this is the main idea of the or the main concepts. And then the idea is that you will see there is a list of things to consider, and then we have to, of course, choose the ones that are most relevant for the product. Then we take that subset, and then we see for each of the important ones how good has been our choice comparing to the state of the art. So are we taking the best possible way of dealing with this, or are we not doing less than that? And then the rough idea is that we try to translate that into a score or into a graph. You will see an example later. So for instance, here we have the list of the main 3 circularity aspects. And for each of them, we have a code and a definition, a circularity indicator. Of course, in the standard, there's a detailed description of these indicators. There are many, as you can see. So we choose some of them, and then we choose the ones that are most relevant, and then we look at them. And again, in the standard, there's a detailed definition of what means high, very high, low, very low for a specific criteria. So according to that, agreed criteria among the experts, you can tag one of these possible 4 scores or grades. And then in the end, what we do is for a given design, we for instance, give it like a number, a score. The number in itself is not that critical, but here, for instance, you can see that in this diagram, you see the 3 main aspects, and then for each of them, we can say this is an example of a 5G active antenna radio, and then for each of them, we say, well, how high is this score? And then, well, you see here, for instance, depending on the color, we have different levels, and then we can see if this design, how good it is compared maybe to other alternatives in the design. So as I said before, the final number is not that important, but I think it matters the most is just this assessment of important things, which ones are those, and what is the margin of improvement, or how high is our, let's say, effort in that particular aspect. And it allows us to have an idea about it and talk to other designers and use the same concept. So that's basically the idea of L1023. Of course, there are other standards which focus more on, let's say, on publishing the information. So in a way, this is intended for designers, but if it were intended for buyers, then buyers would like to know about this information to be able to compute their own scores and choose the product. This is not the objective of L1023, but it's, for instance, the objective for other recommendations that look, for instance, to the digital product passport or similar like that, which try to offer information to other stakeholders. As I said at the beginning, all of them require some kind of support or harmonization of ways to do things. And today we focus on the design phase. Yeah. So that's all from my side. I'm looking forward to your questions. Thank you.
Thank you, Leandro. This was very insightful. I see we have 7 questions on the chat, and I think we are in good time. So I may allow for 5 questions. So I'll read through and you can give the answer straight, or answer live. So the first question we have to you: how are the end-of-life ICT products managed to maximize recovery of valuable materials and minimize environmental impact?
Mm-hmm. Yeah, well, this is not in the design phase, but it's in the recycling phase. Of course, if products get designed in a way that it is possible to, let's say, identify, separate, and extract these valuable materials, critical raw materials, or even any risky materials as well, that facilitates a lot the recycling, and it reduces, I mean, the complex processing of e-waste to separate things which are tightly intertwined. So there are other standards which talk about the methods to recover materials. Sometimes it might be possible, but it's too expensive. And then, well, money makes a difference. So design for recycling means you think about the product to be used, but also to be, I mean, to be used by end users, but also to be used by recyclers, so they can have simple ways or easy ways to separate the different types of products. I can explain more, but I think that this is mainly the relation with L1023.
Thank you, Leandro. This is still another question from Isatu Sar. He has a number of questions, but I guess the third one will have to go to Madban. But I picked this one that asks, to what extent are ICT goods remanufactured or refurbished to extend their usable lifespan? And what quality, standards, and certification processes are employed in remanufacturing and refurbishment practices?
Yeah, well, it depends on the product. There are certain ICT goods which are designed for a longer or shorter lifespan. Let's say L1023 is not focused on specifically on facilitating that process, but just enabling it. Comparing, let's say, two possible designs, refurbishment might be easier or not, depending, for instance, how easy it is to disassemble the product, or how easy it is to find spare parts, or how easy it is to get documentation about the ways to disassemble products. Or so it's not only what you do in the design, but also which information goes with the product, so that these operations can be done and can be done efficiently. And then, for instance, we are working in question 7 in one standard that allows to is one aspect, a very particular aspect is focusing on data wipe, on deleting data on devices, and be able to certify that the deletion has been done correctly, because sometimes one of the obstacles for reuse is that we do not fully trust that any personal information would be left in the device. So we have to provide a harmonized way of ensuring that there's no personal information left on the devices, because sometimes we tend to store it at home because we don't really, or at work because we don't really trust what could happen afterwards. Yeah, I would say this is the most related work we are doing in that direction.
Thank you. So Madban is asking, do companies get a resilience score? Is it part of the study? I don't know if that was answered, because then he has call.
Well, I'm not sure what you mean by resilience here, but probably, yeah, there's a mention in the I mean, if in the detailed documentation of L1023, yeah, it talks durability is related probably to what I would understand as resilience, or robustness, or something like that. So it's not that companies get the score, is that at least in this approach, is that products get a score, or even designs get a score. So L1023 is about designs that could be scored. But of course, and this is beyond the ITU-T work, there are countries which pass regulation that requires, for instance, that when consumers look for products, they should have access to different scores that have to do with different characteristics of the devices, so they can, let's say, buy smart, or be informed at the acquisition moment. But it's not part of this study. But it might be. I mean, there is a boundary between what is, let's say, governmental regulation and what is standardization. I mean, every country or every region, every city even sometimes can come up with their own regulations, but sometimes you need like a detailed specification about how to do that. And of course, the more harmonization, the better on the technical part of it, how to do things, but the choices typically come in regulation.
Thank you, Leandro. So I'll ask two more questions. I'm looking at the time. So I'll ask from Christine. Christine is asking, do the design elements take into account the variation in research and development and manufacturing capacity varies? Do the design elements take into account the variation in R&D and manufacturing capacities, varies countries, and affordability of devices? I don't know if that is clear.
Yeah. Well, I think that is partly addressed. In fact, L1023 has been, let's say, released twice in 2020 and 2023 because of the evolution of regulatory or standardization elements that are taken into account. So yeah, there is an effect on R&D, on the evolution of technology through the evolution of standards. And regarding the capacities across countries, not so much, I would say, because the ICT goods are kind of quite global. The supply chain is quite global. But as I said in the presentation, the objective is not to compare the score of one product with the score of another product. The main goal is that you as a designer in working in a company, you can think about choices and translate it into something tangible that you can discuss with other friends because you are sharing a language. So yeah, I mean, it can be applied in different countries. And of course, yeah, the circularity choices have to do with affordability, of course. But affordability, you can think on it as the price do you pay when you buy it. But of course, if you think about how long does it last, then, I mean, high price can be lower price, let's say per hour, per week, per month, because it lasts much longer. So that depends on your choices. But I mean, at the design phase, of course, cost is determines a lot.
Thank you, Leandro. So I'll ask one more question, and we do have quite a number of questions. However, the question I'm choosing is really on the design aspects to leave alone the end of life because the topic was on really design. So I'll ask a question from Bamba, and it will be our last question, unfortunately. So how does circular design influence the development and manufacturing of ICT products?
Yeah, well, I think it's really important. It's like imagine translating the question to how influential is the architect when you build a house. So many times, most of the choices in the construction phase, in the manufacturing phase, gets determined by the, let's say, the architect of the product. So yeah, and usually the manufacturer is paid by the brand or by the designer company. So a lot of that. Of course, there might be choices coming from part suppliers. So, but I mean, again, the designer is the one typically that chooses which components to buy and which qualities and so forth. So that's why we say that eco design predetermines everything. When the product is conceived, I mean, manufacturing is done according to these specifications, and therefore you simply, let's say, in a way, the manufacturer can have limited choice. Maybe parts can come from different suppliers, but they should be more or less equivalent. So yeah, it's critical in the circular life. Yeah.
Thank you very much, Leandro, and that is all the time we had for the questions. And as we wrap up our session, we would like to express our profound gratitude to you for your enlightening insights on assessing the circularity of ICT goods. We trust that this session has provided you, the audience, with a better understanding of this intricate and dynamic field. Thank you all for your participation in today's Ask the Expert session. Be sure to join us for our next session, which is Land Reborn, reading the digital footprint for land restoration, which will take place on June 5th. For more information, please visit our website. See you next time, and goodbye.
Goodbye. Thank you.